As you know, the idea behind the technique for solving first-order separable differential equations is to collect all the y terms on the left with dy and all the x terms on the right with dx, and then to integrate both sides simultaneously. And that's what we're going to do here with number 5 from page 451. The problem is that we need to solve 2 times the square root of xy dy dx equals 1. And they've indicated that x and y are both greater than 0. The reason they did that is because otherwise this square root would get a little crazy, wouldn't it? Can't have a negative sign, a negative number underneath the radical. So let's go ahead and do our technique for solving first-order differential equations. First thing I'm going to do is go ahead and split this square root into the product of 2 square roots. So that'll give me 2 square root of x, square root of y, dy over dx equals 1. Now I'll go ahead and do the algebra in a couple of steps here. First, I'm going to multiply both sides by dx, and that'll give me 2 square root of x, square root of y, dy equals dx. And then I am going to divide by the square root of x. So on this side, I'll end up with 2 square root of y dy, and then over here I'll end up with 1 over the square root of x dx. Now that we've collected the terms, y terms on the left and x terms on the right, we can go ahead and integrate both sides. On the left it's the integral of 2 square root of y dy, and on the right it is the integral of 1 over the square root of x dx. Now a lot of students work better with fraction powers as opposed to radical signs in their integrals, so let's go ahead and get rid of the radical signs here. I'm also going to pull this 2 out front. So this side is 2 y to the 1/2 dy, and this side is x to the negative 1/2 dx. Power rule for fractions with antiderivatives. On this side we'll end up with 2 times 2/3 y to the 3/2. Now there is a plus c here, but we're going to combine it with the plus c over here and just have 1. On this side we'll have 1/2 x to the 1/2 and then, like I said, we'll take the constant from the left and the constant from the right, put them together and come up with some other constant. We'll call it plus c. Hopefully you've noticed that this 1/2 is really a 2. And I could have edited that out, but I suppose it's good for you to see people make mistakes as long as they catch themselves. When you divide by 1/2, which is what this would be, you end up multiplying by 2. So that's a 2 there. Okay, now I've got a 2 on this side and a 2 on this side. I'm going to divide everything by 2 to get those to cancel. This constant I can divide by 2 and it becomes some other constant. Now I've seen the final solution to these equations written several ways, but going by what I see in the back of your textbook for the answer, what they do is they then recollect the terms on the left side. So they get 2/3 y to the 3/2 minus x to the 1/2 equals c, and they stop. Now some people will go ahead and solve this for y equals, which you can see gets kind of ugly. But we're going to go ahead and leave it here because that's what our back of the book says. Not because the book's always right, but because I know that a lot of times when students do homework problems, they check in the back of the book, and when they don't match, sometimes they freak out. But there you have it.